Hello, everybody. My name is Ronnie Aron. I'm one of the founders of Skyline Software Systems, and today we're very proud to announce a brand new product for massive scale 3D reconstruction called PhotoMesh. And PhotoMesh, you'll see, is a little bit different than the other solutions that exist out there today, and we're going to see how effectively it allows the generation of 3D data sets from massive amounts of images. So first of all, what is it? PhotoMesh can generate 3D models automatically from photos taken from the air, from the ground, and from other ways. And it can actually generate very accurate 3D models from those photos. So you get to see all the details. This is very different from the traditional way of creating 3D models. You actually get all the small details of trees and fences and cars, everything else that's in the imagery. PhotoMesh was developed from the ground up using state-of-the-art technology that's available today. And it was designed from the start to be able to handle the massive amounts of images. And we're talking about tens of thousands, hundreds of thousands of images per project potentially. And imagery today is collected with a variety of different means, starting from the high-end collection using very high-end cameras with 100 or 200 megapixels, down to the drones that can collect images even with a GoPro camera. The trend is that these data collections are getting bigger and bigger. And the more the sensors get bigger, the higher the resolution of the imagery and the fidelity of what we can get with them. So PhotoMesh is unique in that it can handle very large data sets of imagery. It utilizes multi-core and multi-computer techniques to actually divide a job into small tasks and be able to delegate these tasks to numerous machines. And this was designed from the ground up to be compatible with cloud computing so that you can leverage the power of the cloud to get very big jobs done very quickly. Another thing which is unique about PhotoMesh is that it can run on standard hardware. You don't need a dedicated piece of machine to run PhotoMesh, so I can run it on my laptop. It can use the video card, the local GPU, on any kind of machine to leverage any kind of power that you have in the machine. And it generates very optimized 3D databases. Another unique thing about PhotoMesh and about our technology is that these data sets are not just a mesh, but they can actually be annotated, and they can have information coming in from different feature layers. Now, the current state of the art in this domain is that you can run 3D reconstruction. There is 3D reconstruction software out there, except it would take a very long time typically to complete a project. It might be many days, weeks, and it's not unheard of to have a project run for months, depending on the number of images that you have in the project and their size. So people came up with solutions where you can actually distribute the job to multiple computers. So you can run them on 4, 6, 10 computers, and you can get the job done quickly. But it doesn't work with very large data sets. It still takes months sometimes running very large jobs in these ways. So what we did is we designed a system from the ground up that can work with hundreds and potentially thousands of machines in parallel. And these machines can be on the cloud, or they could be on a private cloud. It doesn't really matter. But the system is compatible with running it in a very large scale. And the benefit of that is that now you can complete a project in hours that before would have taken weeks or months. And this is key. It's very important because the data collection doesn't just sit idle. It's not that you're collecting a city and then you have 3 months to process it or 6 months to process it, because in many cases, by then the data is already outdated. And you need something that can handle it very fast. So this is an example. You know, we did a project running on the AWS, Amazon cloud, using up to 500 machines. And this is arbitrary. You can use more machines for larger projects. And the 6,244 images, we completed the project in under 5 hours. And the key here is that the cost is very low. In essence, the actual use was around 1,250 instance hours, which means machine hours on the cloud that were actually being used. And at a cost of about 15 cents an hour, this comes to roughly a bit less than $200 just for the cost of the computing power alone. And this gets to a point where it's actually low enough where you can afford to do this on a very massive scale. You can run 5,000 machines potentially and get a job if you have 100,000 images, again, done within potentially hours. And this is unique. I think that no one else currently is getting even close to this kind of level of performance. And to go along with this, we're introducing a completely new business model of how you're going to use the software. Whereas typically you buy a license, and if you need more machines, you buy more licenses, and the cost can get dramatically high. If you need 100 machines to process very large projects, the cost would go through the roof. What we're saying is that we're going to have a system where you pay based on what you're going to be using in the input. So we're counting the number of gigapixels in your images, and this is the key of how we factor the price of photomesh. You can use as many fusers or machines as you need for the project. We don't limit you. Our interest is that you're going to get the work done as quickly as you can. And the other thing is that you can actually produce projects with a watermark in an unlimited way. So basically, we only make you pay once you decide that the data is usable for your production, for what you want to use it for. And then we give you a key that releases the watermark from the project. Now, this model we don't think it's going to fit the entire industry, but we think that for commercial customers, it would align very nicely with the way they're actually doing their data production. For government customers, we're introducing a different pricing mechanism where it's going to be an affordable annual license. And again, they're going to get an unlimited number of users that they can use. We want them to finish the projects fast. But they're not doing this as a business. So this is a different way. And the other thing that we're introducing is a turnkey solution where you would be able to access the cloud without a need to install any software or do anything on your side. Only log in to your AWS account, and it's going to be there. We're going to have an image of a machine ready with photomesh on it. Photomesh is going to use as many fusers as it needs automatically on the cloud. So this is a turnkey solution, and the only issue you're going to have is how do you get the data over to the cloud, which becomes the bottleneck in these kind of projects. It's no longer the processing, now it's moving the data around. Luckily, Amazon also offers a way where you can send a hard drive with the data on it, and they load it onto your machines. And for the lower end market, we're also going to offer an introductory starter package where you're going to be able to acquire a license. It's going to be an annual license which would get you started with running small projects. Once you reach a limit with these kind of projects, you are always able to switch over to the gigapixel flex model. And you can produce your data with watermarks, again, with no limitations on the number of machines. So we've talked about photomesh for producing 3D data, but photomesh is only a first element in what Skyline is offering. The Skyline offering allows you to take these photomesh models and display them in real time, in 3D, stream them across a network, fuse them with different types of data. So you can load your BIM models, you can load your point cloud models. You can load your spatial features and anything else which has any kind of spatial connotation, imagery, elevation layers, and so on. All of this can be visualized dynamically on any kind of device. We support iOS, Android devices, so you can take it mobile with you, desktop, and the cloud. We also offer very sophisticated 3D analysis. So from elevation profiles to measurement tools and view shed analysis and shadow analysis. And we also offer a collaborative environment where people can collaborate across a network. The private cloud services is where you can set up a private cloud for your organization. So this is for enterprise customers that want the data in-house. We offer private cloud systems where you can host terrain data, the 3D mesh data produced from PhotoMesh, along with any kind of spatial feature data. These private clouds are basically open with using OGC standards, so you can use other software to tap into them once you set them up. And they're bidirectional, so they can pull data from your other servers, whether it's an Esri database or it's an OGC database. They're also sophisticated in a way that allows you to do editing. So we support WFST that allows you to do transactions on these data layers. Talking about some of the applications, and these are the industries that Skyline is involved in today, which includes the defense and intelligence, geographic portals, which goes to another extreme, public safety and security, mining, oil and gas, and so on. And inside of these industries, we have a multitude of different types of applications. So, for example, in defense, this is being utilized for mission planning, asset tracking, command and control, and many other types of applications. And commercial applications include planning and simulation, and we're going to see some examples of that, command and control, urban planning, and again, many, many other types of applications. And as a good example is our joint venture in China, where they have over 1,000 organizations as customers using the Skyline Globe technology. Smart Earth is our joint venture in China, and they are creating solutions which span from the data collection through the utilization of the data and customized applications. And this uses the full stack of the Skyline software products, with PhotoMesh now coming as a new product. I think enhances that significantly, because now 3D data is going to be much more abundant, much more available, much cheaper to produce, and at much higher fidelity. And this would feed into all of these different types of applications, allowing for very high fidelity visualization. So to show you PhotoMesh in action, we have this short video segment. And producing a 3D mesh, again, is nice. Everyone likes to look at it. But we think it's a key to all of these kinds of applications. So this demonstrates some of the capabilities of what you can do in addition to the 3D mesh visualization. We can load in feature data layers from standard formats, from databases, from files. We have very sophisticated analysis tools that let you do spatial type of queries and analysis. You can bring in your imagery layers. PhotoMesh also produces orthophotos and DSM, which you can load onto your model as an orthophoto. These are some examples of the kind of high fidelity, high quality models that you can get from PhotoMesh that you're going to see. We also allow you to merge this with point cloud data, and you can do analysis on the point cloud data, from measurements to the different types of way of visualizing the point cloud data. Massive amounts of point cloud can be streamed across a network and visualized. And this is switching to the PhotoMesh view, which shows you the high fidelity and what you can expect to see from the PhotoMesh production. This is from 3-4 centimeter data. That's over in Frederick, Maryland. And the 3D accuracy is fantastic. it's very close to the resolution of the imagery itself. Now remember, I mentioned that this is not just a plain mesh. It can actually have some smarts behind it. So we're using feature layers, like rooftop layers, where you can actually select specific buildings and see the information on them. And you're going to see that in the presentation. So traditionally, if you're doing 3D modeling by hand, you would never get to this kind of high fidelity. So this shows a combination of how you can use this for critical infrastructure type of visualization and management. So it shows the underground ability of Skyline Globe, where you can go under the ground. We have tools that can take a feature layer and turn it into pipes. So any kind of GIS layer, then you can visualize it. And you can do measurements such as terrain volume analysis, which very accurately, because of the accuracy of PhotoMesh, would give you the information of how much soil do I have to remove from somewhere or to add somewhere. This is also something very unique, I think, that we are currently doing, is the ability to take live video and project it onto the 3D mesh. So this is a dynamic display of what's going on in the scenario within the context of the scene. And you can use terrestrial security cameras, you can use aerial cameras, and you can get the view of what the aircraft is actually seeing. This is another cool thing that we can do with PhotoMesh, is you can do dynamic viewshed analysis from a moving vehicle. And then we can also go underground. This is really cool. You can actually excavate a piece of the terrain, and you can add your BIM models or your 3D CAD models. And you can actually use them within the context of the bigger picture. So you can do a walkthrough inside of the building. And in the future, we hope in the near future, PhotoMesh would also be adapted for indoor spaces. So you can take your imagery, panoramic imagery, inside a building or a structure, and you can create models like this that you can do walkthroughs in. And remember that this is not only a fly-through, but this data is actually actionable. You can measure on it. You can do viewshed analysis, line of sight analysis. All of that is actionable within the 3D view. And this is all workable on a laptop as well as on a mobile device. So if you have your iPhone or your iPad or an Android device, you can use this technology directly on it, and you can do the full analysis capabilities is on all of these devices. So public safety, visualizing an event that's happening. We can do a spatial query to find a location within the 3D database. Again, you get the full picture of what this area looks like, which is important for a fire crew that's going to be heading there. They need to know how many stories are in the building, what it looks like, where are the exits. And you can do live tracking of any kind of vehicles. We have examples where many thousands of vehicles can be tracked in real time. And you can use this for training environments as well as for command and control environments. We could do buffer zones around the power lines to give you a visualization of where the danger might be. And we can also highlight models. As I mentioned, the models have some knowledge behind them. It's not just a mesh, but you could actually query which buildings are in the surrounding area, and you get them marked in the 3D. So we can highlight specific buildings or specific models inside the scene. Some analysis capabilities include elevation profiles that you can do on the mesh, not just terrain. And you can compare multiple profiles within one view. And this is another cool analysis capability, is a Skyline View. which provides you the view of the skyline from a specific vantage point. And you can create what-if scenarios. What's going to happen if I put in this shopping mall in there? How is it going to change the skyline from specific views? And the model, again, can be a very simple 3D model, and can be a sophisticated BIM model with unlimited size and level of detail. This is some multiple view shed analysis capability, which shows you, again, what happens if you remove a tree. How is it going to improve the visual effect? We can also do a combination. And this is dynamic, so if something is moving in there, you're going to see the effect. And we can do multiple view sheds to allow you to calculate where best to place a security camera, for instance. So this would give you a result showing the analysis of which points are visible from how many cameras. And you can see if you have dead zones, and you can correct that. Real-time shadow, so you can select time of day and the date, and you get the actual shadow. And it's interesting because in looking at the 3D models created, we can actually tell within an hour of when they were generated just by measuring their shadows. And we also have effects for environmental simulation. So whether it's fog, rain, or water effects. So we use a sophisticated particle system. We give you a big data library where you can do urban planning with it. You can add trees and so on. And you can do time events. So measuring a flooding level based on time and seeing the effects. We have flood analysis tools that allow you to do that. And all of these effects are also affected by wind speed. So if you have smoke and you set the wind at a certain speed and direction, you're actually going to see the effects being affected by it. So if you have rain in the scene or snow, you can get this realistic effect. Thank you very much. Now go and build something.